So morning everyone, I'm Jeffrey. Today I will introduce the SuperMap optical photogrammetry solutions and cases. So today our presentation will be separate 5 parts. So the first one, I will show you some concept or introduction of the optical photogrammetry. Then there's some challenges, and also I will show you how to integrate the optical photogrammetry with GIS. And then I will give you some example or some applications and how to use the optical photogrammetry data for the project. And the last part, I will show you some demonstration in our platform. So show you some how to use the optical photogrammetry data and integrate it with other model. Yeah, so now let's start. So the first part, we can have a general introduction of the optical photogrammetry. So as we mentioned, the optical photogrammetry, we need to start from some traditional 3D modeling. So for some traditional way, we use the artificial measurement or some photogrammetry or some artificial modeling to make the 3D model. Like we use some 3ds data from 3D Max or some data from AutoCAD. And we use data to build the 3D model manually. But in this way, there's some disadvantages, like it's not real and also the lower precision. And also it has a higher cost. So we provide the optical photogrammetry to solve these several problems. So for this technology, we'll use the drone or some aircraft to capture some images. So we need to have 5 images. So one is from the vertical angle, and another 4 is from the optical directions. So use this 5 images, we can do some data processing in some optical photogrammetry software. Then you can generate the OSGB format, and then SuperMap can provide the platform and let you do the data visualization. So this is the first picture is the sensor of the machine, and then it's a picture to show the how to capture the images from the ground. And this is also a picture to show the different picture from different direction. So you can see, like, if we want to capture one building, we need to have the one from the vertical angle and another 4 from the different direction, like this. And so after we collect the data from some drone or aircraft, we need use the optical photogrammetry software to do the data processing. You can also call it modeling. So SuperMap now supports some mainstream modeling software like the Street Factory or CC, the context capture, or the PhotoScan, Artizone, or Pix4D. So you can select one of the software to process your data, and then you generate the OSGB format, and you can use SuperMap to load the data. So this is one of the example to show the optical photogrammetry data for one of the city in China. So for the optical photogrammetry modeling, we have some advantages, like the high efficiency, high realism, and high accuracy, and also the lower cost than some traditional way. And after we know the knowledge, so here we will show you a workflow. So you can, from this workflow, you can see actually SuperMap provides the GIS platform, and before SuperMap, we can cooperate. So you can see from here, we cooperate with SuperMap partners. So they will use some aircraft or drones to collect the data, and then also do some modeling, help us do some modeling, and then we will load this data in our GIS platform. So after that, our partners also can use our GIS platform to do some applications in different industrials, like the smart city or the urban planning, and also some the security monitoring. So you can see this is one of the effects. We load the optical photogrammetry data in SuperMap platform. So after we get the optical photogrammetry data, you can see we can provide the ability for different industrials. As we mentioned, also we can do for the surveying and agriculture, and also the water resource management, even for the oil field. But for this data, also we have some advantages, but it also have some challenges. So it's very important for us to solve these challenges. So the first challenge is the data of the size is very big. So you can see this is one of the example. So you can see actually we have to load this data in the web browser. So we have to do some optimization to load this data. Yeah, so here I will show you how to manage the large scale of the optical photogrammetry data. So the first way, we need to use some function to higher the performance. So you can see we we need to generate the cache layer, and also remove some suspected parts, and also we need to use the distributed storage like the MongoDB database to storage this kind of data, and also we can have the dynamic projection, and also sometimes we need to merge the root node of the OSGB data. And here is workflow, like we need distributed file system to prepare the OSGB data. Then we put them in the distributed database and convert to SRAM, do the distributed operations. So after that, we can put them in the distributed database, the MongoDB. Then we can publish to the web service for some applications. And also when we process the data, we also provide some ways to higher the speed. Like you can see, for the traditional way, we use the standard long mode. So for one of the data, we have to use almost 1 day to process the data. But so far, we have the distributed processing mode. So it only needs 3 hours. We can finish our work. And the second challenge is for the object expression. So as we know, after we get the data from the drawing, it's just like some 3D image. So all the data is continuous. So we need to have some ways to solve this problem, because in the real project, we have to storage all the information for each building. Like if we want to click this building, we need to check the real attributes. So we need to have some way to solve this problem. So how to solve this problem? We can talk from the some 2D. So for the 2D, like now we have a satellite image, and also we have the vector data. So we can put these 2 layers together to overlay these 2 data. And then if I click this building, So it will actually connect the vector data. So we can read the attributes from the data. So for the 3D, it's similar. So you can see here we have the 3D model, the optical photogrammetry, and then we also overlay the vector data with this model. So, and we do the objectification. And then if we click this building, it will be highlighted, and also we can get the attributes information from this building. So this is our solutions. So you can see this is one of the example. So now we just draw a polygon to cover the range of this building, and we type some information for this building and submit. And then when we click this building, it can connect the attributes information. And also, you know, if we only use the vector data, but for some area we don't have that data, so we also provide using the deep learning technology to help us extract the vector data. So you can see we have the 3D images, so we can extract the base of the buildings and also separate them in a dynamic way. And so after we extract all of the building, so even we can make a thematic map to separate the buildings in different levels. Like in some real project, we can separate the price of each building using different color by this way. And the next challenge is sometimes we cannot get all the good effect of the optical photogrammetry data. So for some parts, we have to make some modification. Like here, you can see from this picture here. Because in this project, we have to use the optical photogrammetry data with the terrain. So we have to overlay with this 2 layer. But here, the optical photogrammetry data was overlaid by the terrain. So we have to remove them. So you can see we can do the effect repair. So after that, we can have a good effect. And also for some cars, the effect is also not good. So we can do we call it flatten. That means we can flatten the road and put a new texture overlay with the road. So you can see the difference. And also for some parts, like the trees or some like the bus station, the effect is also not good. So we can remove the suspected objects. And this is an example. You can see we will remove this part and set a new 3D object here. For SuperMap, we provide some default 3D model for the like the trees or the bus station or the cars. So you can just draw a 3D point here. Then you can do the symbolization, set the different model, set a different object here. And also for some parts like here, the road is still under construction. So sometimes we want to see the future effect. So we just draw a line, and then we also do the symbolization. So we can set a new road here, like this. And also for some parts, you can see because for the optical photogrammetry, if we want to collect some dynamic dynamic data, so there will be some problem. So for the water surface, when we do the data processing, we have to modify it. So like here, we draw a new polygon, and also we set the dynamic water surface for this polygon. So we can change to this picture. And also, you can see this is another effect for the water surface. This is a city in Germany. And then after we solve these three challenges, we need also, we cannot only use the oblique photogrammetry data, because we have to analyze the oblique photogrammetry data with some surroundings, with some environment. So we have to integrate it with GIS. So if we want to integrate it with GIS, the first is we need to do some data operation, because for some parts, we only need a part of them. So here you can see one of the example. We extract or we clip the building from the optical photogrammetry data by the GIS spatial data by the polygon. So this is one of the example to show the integration with the GIS. And also we provide some like the mosaic or dig by the 3D polygon. And also we can do the texture replacement. And also for some area, we have to have the comparison. So here we also provide a function called historical version data management. So here we can compare like the current data and also the old data. And also for the GIS, we can also provide some 3D analysis functions. Like here. Here, this picture is to show the tunnel. And also for the tunnel, you know, we have to integrate this data with the terrain. So we have to do some modification for the terrain, then put the tunnel inside the terrain. So here we call this function is the spatial operation. And also we can, after we do the objectification, we can also provide some spatial query like this. So here you can see the red line. Sorry, if we want to build a new road by this red line, so we can generate an area. So you can see the red part. So now we can calculate how many buildings will influenced by this new road. So this is one of the cases or the applications. And also we provide 3D analysis like the visible analysis, skyline analysis, shadow analysis, and also the view shade analysis. And later we will, I will show you some example from a real project. And here, this is the example to show the skyline analysis. So you can see from this picture, yeah, if we stand here, and so we can generate the red line. So it's a skyline for this 3D scenes. And also, not only to show the effect, but also we can export the analysis result to a 3D solid. And then we can do more analysis using this 3D solid. So you can see the blue part is the solid. And also this is an example to show the visual domain analysis. So in the new version, we also can support the 3D solid to save the result. And for more function like the shadow analysis or openness analysis. So this kind of analysis can be used in the urban planning. And also we use some JS technology to provide some 3D simulation. Like here, in some agriculture project, we have to use the DM data. Also, we need to have the 3D, the optical photogrammetry. So we have to overlay these two data. So here we can also use the DM to analyze some slope or the aspect. So here I also do an example. This is to show the slope and aspect analysis. You can see I just draw a polygon, and then it will analyze in real time. And then it's Isoline analysis. It's also in real time. Just use the DM data. So we just also draw a polygon. And even we can change more parameters, change the color, or change the height. And this is one of the application we use the optical photogrammetry data. So you can see we will simulate the flooding in the city. So let's see it again. And also for some, in some city or some country, there's some problem about the air pollution. So we can also provide the ability to help you do some analysis. So you can see even for the one single building, we can check the different air pollution rate in different height. And also, not just the some simulation or some digital data, we can also do some output. Like here, we have the optical photogrammetry model, it's 3D model. Then we can also generate the DSM, DRG, DOM, or some street elevation using our software. And also we support a 3D printing. We support the format, the STL. So after you do the modeling, and then you can generate the STL format, and you can print it, use a 3D printer. So this is a result. So after we know how to integrate the optical photogrammetry with the JS data, so now here I will show you some applications using this technology. So here, in the some urban planning project or some smart city project, we need overlay the because we need to know the real status for the underground pipeline. So we can overlay with these two data. We can drag the ground and select the pipeline and check the attributes. And also here we provide some functions for the urban planning. Like here, I draw a polygon, I select a model, and input. So we can set a new building here. So you can see that actually for the base map is the optical photogrammetry data. And here we just draw some points. Yeah, and it can be showed as the 3D model for the trees. Yeah, and also we can draw some new polygon. Yeah, like here. I draw a new polygon, and I can set some dynamic water surface here. And also, in some real project, we can also do some comparison, like here. We set two different building, and we do the comparison. So the base map is also the optical photogrammetry. And also in some urban planning project, because in some city we have the limitation of the height for the building. So here we can calculate which building over height. And also we can use this kind of data in the 3D real estate platform. So in some real project, we not just click one building to check the information. So here, even we can check the attributes information for each room. So you can see here, when we click this room, it will be highlighted and we can get the information. And also in some natural resource management system, we can also provide the you can see from here we overlay with some vector data. So in some project, if we only have the optical photogrammetry data, it's not enough. So here we also provide the ability to integrate the multi-source data. So here, yeah, we already show it. So here we can integrate it with the 3D line, and also here we integrated with some BIM data, the building information model. So you can see some project we overlay the BIM data with the optical photogrammetry. So this is a dam management system. And even we can connect the real-time video to connect some IoT equipments and overlay the real video with the optical photogrammetry data. So you can see this is one of the effects. Yeah, and also we can combine with some street view. You can see we can switch from the optical photogrammetry data to the street view. And also in some civil engineering project, we can also put the 3D model with the optical photogrammetry data. So this is about the industrial park management system. And so for the visualization, we not only support the PC terminal, but also we support the web browser as we saw, and also we can support the mobile application. So you can load the optical photogrammetry data in your mobile. Yeah, so then I will show you some applications or the real cases using this kind of data. So this is a urban planning project in Germany. So you can see we use the drone to collect the data. And here we provide we call it particle effect. You can see we can set a fountain effect. and also the weather effect to make the 3D scenes more beautiful. Even we can also provide some effect like the smoke or the fireworks. And after we get a 3D image, we can also overlay with the vector data. So you can see we set the different colors so it can show the different land use for this area. And also for the optical photogrammetry data, not only a visualization, but also we can do some measurement, like we can measure the area for this part. And also we can measure the distance. Yeah, we just select some points. Yeah, also the flooding analysis, flood simulation. It's very interesting. And also for some urban planning, we need to get the profile for this city. So you can see after we get the profile, and also we can measure the height. We just select 2 points. Yeah, the distance, the height for this building. And also we can do the skyline analysis. Yeah, this is a skyline for this city. Yeah, let's play it again. And also for some civil engineering project, like the traffic road planning project, we can also put the road overlay with the optical photogrammetry data. And overlay with the underground pipeline. And also for some the dam, we can also use this kind of technology. And even for some emergency management system. So optical photogrammetry can also provide the base map, base environment. Then you overlay with some points or some, you can see the model of the car and also some dynamic effect. And also for some monument project. This is one of the project in China. Yeah, because sometimes if we use some surveyor to collect the data, it's very difficult, and so we use the drone to collect this data. Yeah, so this is all the presentation from my side, and then the last part, I want to show you some demonstration in our platform, so maybe you can give you more ideas. So let's go to the software. In order to save the time, so I have already opened the software. So you can see this is interface of our desktop software. So we integrated all the function in one application. So you can see we also put the 3D function in this module. So here I will load the optical photogrammetry data. So you can see actually it's just like a 3D image. And here we can do some measurement. Yeah, like we can measure the distance for this building. And we can also measure the area. Let me select maybe here, and I just draw area, select some points. Yeah, so you can see. Yeah, we can select like here. Yeah, and also for the height. Yeah, it's very easy. And also, I not only just do some measurements, but also like here, we can do some modification. So here you can see this building is very old. And now I want to remove this building and set a new building here. So here I will create a new KML layer to connect with the 3D model. I just set a name. And then I connect the model. And here, before I connect the model, I need to remove this building. So we use the model flatten. So here, I also draw a polygon to cover this building and right click. So you can see, now we remove this building. And here, I go to the KML layer to connect the new building. Yeah, I add the model. And give a point here. And here we need to adjust the scale for this building. And move. Yeah, just a demo. So you can see we can put a new building here. So for the optical photogrammetry data, you can do some operation or modification in our platform and can empower your JS function. And then for the big scale of the data, we also support, so I will show you a demonstration. It's also it's a real project. Yeah, we can use this directly. Yeah, because I prepared before. Here, let me load the data. So you can see actually for the mountains is the optical photogrammetry data. So you can see. Yeah, so this is a real project in China. It's about the dam management system. You can see the main building, the dam. And here, why I want to show you this project, because you can see like the The bridge actually is the 3ds model. So we can overlay the 3ds model with the optical photogrammetry data. Because for some parts, we need use the some manually model, like the building. Then we continue. The dam. And also for the water surface, as we mentioned here, actually, you can see this data set is just a polygon. And I set the dynamic water surface for this polygon. So we have the dynamic water effect. Yeah, so I think for now, maybe you already have some ideas. So in the Q&A part, we can have more discussion about your ideas. So that's all for my presentation. Thank you very much.